Hello guys, welcome to the Right Brothers channel. So today we are going to dive into a topic called artificial neural networks. So before we get into artificial neural networks, let us see what is a neural network. Now we are going to experience a real world example. Get ready. Excuse me. Yeah, here we are able to see that he has taken an input with the help of his receptors, through which the input has been processed to his brain, and his brain interprets the input and produces an output. So this whole function is done by a unit called neuron. So similar as a neuron, we are going to have a node in artificial neural networks. So let us see what is a node in artificial neural networks. Now, as we have seen the real world example of a neural network, let us see what is an artificial neural network. So, as we have neurons in our brain, we represent those neurons, or we try to portray those neurons in the form of node in artificial neural networks. So, this is what is called as a node. Okay. Now, in this node, you are trying to give the inputs in the form of x1, x2 and x3, where W1, W2 and W3 acts as the weight of these edges. Now, this node takes the input consisting of weights W1, W2 and W3, and it performs summation operation here. So, the result of this summation operation is known as weighted sum. Now, this weighted sum is calculated by x1 W1 plus x2 W2 plus x3 W3. The result of this weighted sum is carried forwarded to this f, where this f can be called as the activation function. Now, the result of this weighted sum is interpreted by this activation function. By this, we can say that this activation function defines the output that is to be produced by this node. So, the output of this node can be represented as the activation function f of sigma of wi xi, where this sigma wi xi can be called as the weighted sum. Now, let us see the types of activation functions. First one is linear function, Heaviside function, sigmoid function and tanh function. Now, let us see what is a linear activation function. So, in this, the model that is produced will be in the form of a straight line. So, the output will be f of v is equals to a plus v. This is similar to that of equation y is equals to mx plus c, where here the v is the weighted function. So, now we have plotted this v in the x-axis and f of v in y-axis. Now, as we are able to see, this constant c is similar to that of a, and this mx is similar to that of v. Now, we can write this v as sigma of wi xi. So, as we are able to see that this sigma of wi xi is similar to that of mx. Now, the result, that is f of v, which is equals to 1. Let us get to the Heaviside activation function. This Heaviside activation function is a step function. That is, output in this step function will be either 1 or 0. Now, let us see. Similarly, as in linear function, we have taken v in the x-axis and f of v in the y-axis. Now, if the value of v is less than or equal to e, then the output will be 1, or else the output produced will be 0. So, let me give you a clear example for this. This kind of activation functions can be efficiently used for classification purposes. Here, we will be taking this a as a threshold value, where based upon this threshold value, we are going to classify whether it belongs to 1 or 0. Let us take the same old example, boy or a girl. So, based upon this threshold value, if 1, we are going to classify it as a boy. and if it is 0, we are going to classify it as a girl. Let us get to the sigmoid function. So, in this sigmoid function, similarly we have taken v in the x-axis, f of v in the y-axis. Now, where the output will be f of v is equals to 1 by 1 plus e power minus v. So, the output of this sigmoid function will be in between 0 to 1. So, now we are going to perform some test cases, and based upon that test cases, we are going to take some assumed threshold value for this. That is, let us assume that 0.5 is a threshold value. So, any result that is produced with a value below 0.5, we are going to classify it as a girl, and above 0.5, we are going to classify it as a boy. Now, the difference between sigmoid activation function and Heaviside step function is that we can use this Heaviside function for binary classification, that is consisting of two classes, whereas when it comes to sigmoid, we can divide this 0 to 1 into, for example, let us take 4 classes, 0 to 0.2 and 0.2 to 0.4, 0.4 to some 1. So, based on this, if we get a value in between 0 and 0.2, we can classify it as some class A. If we get the output from 0.2 to 0.4, we can classify it as B, and so on with the C. Hope everyone has understood the difference between sigmoid and Heaviside activation function. Now let us get into the tanh activation function. The similarities between tanh activation function and sigmoid activation function are very more. Now this tanh function, so for better understandability purpose, we have compressed this graph from 0 to 1. Now in this tanh function, same as sigmoid function, we have considered v in the x-axis and f of v in the y-axis, where the output will be 1 minus e power minus 2v by 1 plus e power minus 2v. So, depending upon your requirements, that is, I have told you this Heaviside step function is used for binary classification. This can be used for classes which are having more than 2. So, in order to produce an efficient result. Whereas, this tanh function can also be used for 2 or more number of classes classification. So, based upon your requirements, that is, the gradient that you acquire or the slope that you get. So, based upon that slope, we are going to choose whether we are going to use tanh activation function or sigmoid activation function. So, if you want a more steeper one, we will go for the tanh. Or if you want the one which raises slowly from 0 to 1, then you will go for the sigmoid activation function. So, the most probable values that you get in this tanh function are 0.9 to 1. So, as you are able to see, the line is occupying more space between 0.9 and 0.1. So, the most probable values that you will be getting while using tanh activation function is 0.9 to 1. So, similar to these activation functions, we also do have RELU activation function, ELU activation function, etc. So, based upon those, the mostly what we used for basic projects or the major projects, we will go with these activation functions. So, hope everyone has understood what is an activation function and where do we use it. For further queries, I request you to mention your questions in the comments below. Thank you.